Last time that we saw that when you want to take the derivative of the product of two functions, that you take the derivative of one of the functions, multiply it by the other function, and then add to that the reverse. So you take the first function times the derivative of the second, and you add to that the second function times the derivative of the first. In other words, if we take the derivative of a product, f of x times g of x, we get f times the derivative of g, and then plus g times the derivative of f. Just like that. That is the product rule. So the derivative of f times g is f times the derivative of g plus g times the derivative of f. Now, today we're going to look at why it's true. Now, as always, when it comes to proving a derivative rule, we have to go back to the limit definition of the derivative. So suppose we define, so let h of x equal f of x times g of x. And then we want to compute h prime of x. Well, h prime of x is just the limit. Did it again. Let's not use h. Let's say we want to let u of x equal f of x times g of x. So then u prime of x will be the limit as h goes to 0 of u of x plus h minus u of x over h. You see why I didn't want to use h of x there, because I'm taking the limit as h goes to 0, and h in the limit here is different than whatever I call this function, which is arbitrary, so let me just call it u. So I have a function u of x, which is the product of two other functions, f and g. So u of x is just f of x times g of x. And I want to compute u prime of x. So I just uncan the regular good old-fashioned derivative formula, except I use the name of the dependent variable as u. So it's u of x plus h minus u of x over h. Now let's unpackage this a little further. It's the limit as h goes to 0. Now let's replace u with, express u in terms of f and g. So u of x plus h, I have to take the formula for u of x and replace x with x plus h. So I get f of x plus h times g of x plus h, and then minus u of x, which is just minus f of x times g of x, all over h, like that. Now, you might be looking at that and thinking to yourself, how is something like that going to look like f times g prime plus g times f prime? It doesn't really look like it's all there, but we have a little trick. So this is equal to the limit as h goes to 0. Watch this. We start off by just f of x plus h times g of x plus h. Now watch what I do next. Minus f of x plus h g of x. Notice I snuck this guy in. This is different. I can't just add something to the numerator unless I add a 0. So instead of just subtracting this, let's subtract this and add the same thing. So minus f of x plus h times g of x plus f of x plus h times g of x, and then minus f of x, g of x, all divided by h. So notice that these two terms are exactly 0. F of x plus h times g of x minus f of x plus h times g of x, and that's how I can get away with this. So next I'm going to separate this. I'm going to cut this fraction in half, and assuming, so I'm going to break it apart into the sum of two fractions, and assuming the limit as h goes to 0 exists for both, I can distribute the limit over the two results. So this will equal the limit as h goes to 0 of f of x plus h, g of x plus h, minus f of x plus h, g of x over h, and then plus the limit as h goes to 0 of f of x plus h, g of x, minus f of x g of x all over h, just like that. Okay, now the first expression has a common factor of f of x plus h, and the second one has a common factor of g of x. So we can rewrite this as the limit as h goes to 0 of f of x plus h times g of x plus h minus g of x all over h, and then plus the limit as h goes to 0 of g of x times f of x plus h minus f of x over h. Pull this factor of g of x out, pull this factor of f of x plus h out. So now it's very handy because, well, g of x here is a constant because we're holding x fixed while we take the limit as h goes to 0. So this guy can freely move outside of the limit, and it's just clearly it's g of x times the derivative of f. It's g of x times f prime of x because what's left is just the derivative of f prime. Now this is the product of two functions, which we can then write as the limit as h goes to 0 of f of x plus h, and then times the limit as h goes to 0 of g of x plus h minus g of x over h, and then plus g of x times the limit as h goes to 0 of x plus h minus f of x over h. And I'm allowed to break this apart as long as this limit exists and this limit over here exists. So as long as both of these exist individually, I'm allowed to say that the limit of one function times another. In other words, I can say that the limit of a product is the product of the limits as long as each of the limits exists. So as long as the limit of this one exists and the limit of this one exists, I can, write this out like that. That's just one of the basic limit laws. Well, the limit as h goes to 0 of f of x plus h, I don't know where I'm going to put this, is just f of x. And then times the limit as h goes to 0 of g of x plus h minus g of x over h is just g prime of x. So we have f of x times g prime of x. And then we have plus g of x from here, and then the limit as h goes to 0 of f of x plus h minus f of x over h is just f prime of x. So lo and behold, the derivative of f times g is just f times g prime plus g times f prime, and we proved it using the limit definition of the derivative.